Hi, this is Casey from Denner, USA. I'm here today to talk to you about the DDM series of press brakes. These are servo press brakes. If you can see the name on the upper right-hand corner. When we talk about servo brakes, we mean pulley electric press brakes. These start at this size, which is 5 foot wide and 44 US tons, and they go up to 220 tons and 4 meters long, 13 feet long. The servo brakes are driven by a motor on the back side over here, a German motor made by Lenz, and it winds a pulley belt around on this side of the machine, and separately a Y2 motor over there winding over a series of hubs, a pulley belt on that side. It's a true Y1, Y2 machine, so you can tilt the ram. The neat thing about this is that you can have a smaller amount of force pulling on the first line segment of the pulley belt, but as it goes around the hub, every section, every length of belt has the same force being pulled by the motor. So it's like a block and tackle, it multiplies. And so you can have a high amount of pressure with a low duty force against the motor itself. You can see here on this machine today, we happen to have Wilson upper and lower hydraulic clamping. Normally, it's a segmented individual holders that'll take American or European punches. And on the bottom side, again, hydraulic clamping, but the standard table is 60 millimeters wide to clamp any European base or American manual die block you want to put in there. We offer these American die riser blocks, and so do all the other tool companies. You virtually can put any kind of tooling into the machine. You can see the DDM series brakes are fairly fast. On average, a bit faster than the hydraulic brakes. There's no valves, and so at bottom dead center, when you're finishing the bend, there's no valve change delay. It just rebounds back up to whatever top dead center you made the stroke. You can see on this back gauge, it's a true 6-axis back gauge. We offer also 2, 4, 5, and this 6-axis back gauge. The machine is also very quiet. There's no pump putting out 60 or more decibels to pump the oil. There's very, very little maintenance. The machine comes with a 2-year standard parts warranty. Here you can see the 2 standard sheet supports that come with the machine. Like all our press brakes, these sheet supports and the fingers on the back gauge and the drive motors for the X-axis and the R-axis, these are all driven on Rexroth steel linear gauge. Rexroth made in Germany again. But these 2 sheet supports have chromed rods on the top and a roller bearing right over here. You can move them up and down and adjust them by these little knobs here and match them up to your V-die height if you wish to. 2 come with every machine, and they're quite useful. All our press brakes come with safety side guards, so no one can get in from the side of the machine. As you can see on the DDM series, we have a series of springs over here and another line over here. These are basically compressible springs that push the ram back up. You cannot have a ram that falls on this. You're winding the pulleys to bring the ram down, and these springs push it back up. Very, very simple. You can also see our most popular laser device here, the DSP box laser. It shines through a gap over here on the frames. By the way, there are no C-frames, as you can see on this machine. It's a box frame. The back gauge is as long and as wide as the bending surface on the ram. And so the frame of the machine is outside of the back gauge zone. I'm standing out in front of the machine right now, pressing on the foot pedal, and the camera's behind the machine. You can see the 2 motors on the top of the back of the ram there, made by Lenz in Germany. And you can see, perhaps, through a plate back there, the pulleys a little bit. Again, a very quiet operation, very accurate. The linear scales on this machine are 2-micron resolution, like all our brakes. We guarantee 4/10,000ths of an inch. What you're looking at right now is the numeric input screen for simple numeric programming. You can put in the width of the sheet. You can put in the thickness in inches or millimeters. You can specify the type of metal. This right now it's saying steel. You can specify an upper punch and a lower die. This control comes with virtually every punch and die made by every manufacturer on the planet. And then when we set up this machine, we take the tools that you own and we put them into your working library. If you have a special die that is not in anybody's tool library, as long as you have a DXF of the side view of the part, the top or bottom die, we can put it into the machine, and you can see this in 2D and 3D. We also have here the input for Y1 and Y2. Here I have 90 degrees. By the way, as you program, it automatically calculates the stroke. Here you can see bottom dead center, 11.68578 inches. The X dimension is 3 inches. This being a 6-axis back gauge, I have an X1 and an X2. So I have on bend number 2, shown above here, the two fingers are parallel. Back on step number 1, they're skewed. You can change this to anything you want. If I want to change the width of the part to 12 inches, I just hit 12 and enter, and it updates the program. When you're ready to run, you simply go to the run screen, and you're off to the races. This column over here shows you the current position of all the axes of the machine in real time. Everything over here is just what you programmed. You can set over here inches, millimeters, inside flange dimension, outside flange dimension, or absolute. An absolute flange dimension would be something like you want to bend 2 inches up to 90 degrees right over the bend line. So 2 inches back from the bend line, bend up 9, that's an absolute dimension. You can set the top dead center. This is your return height of the ram. You can set the force. On this little part here, it only calculated 4.1 tons. This is all the machine's going to deliver. If you put two pieces of steel together on top of V-die, it won't form them. You don't have enough force. You can always add more force if you want to. You can also set the bending speed here. You can set the mute point, where it goes from high speed to bend speed. This little machine doesn't have crowning, but if this was a crowning machine, you could set crowning from 1 to 100%. If it was a CNC motorized crowning, it would just do it invisibly and show you where it thinks the crowning should be. Now, this being the ESA 675 control, it comes with a 3D software on here so that you can take step files, IGES files, and you can process them directly here in 3D. So, for example, if I want to open a part, this little button here says open a part, and it brings up, in this case, a folder. This is a Windows 10 computer, so it's like your PC in your office. It has files all ending in IGES. These are a folder of IGES files. I have another folder in here that's all DXF. I have another folder that's STEP. So I'm going to pick on one of these parts. It's asking me what type of metal is this. You can put any kind of metal you can buy in here. I'm going to say it's steel, and I'm going to say open. There's the flattened part. Hasn't done anything else yet. What I'm going to find now are tools. Tools in my working library that will actually bend this part. Let's press start, and you can see right away it's found a punch and a die. That's the highlighted row 1, but there's many, many, many different punches and V-dies it found in my library that'll actually make this part. For example, if I go down to the bottom one here, this is a punch, a V-die, and some other data on the punch tip radius, the V-die, opening, etc. And you can see the picture changed over here to help me select the punch and die I want to use. Let's say I want to use that. I go, okay. So now you can see the tool has shown up underneath my part. I can zoom out, I can zoom in, and now I'm going to press sequence and start. The blue line says it's thinking. It's finding a 6-bend sequence that doesn't have an interference. And there you go, it's found a solution already up at the top here. I'm going to say stop. And let's just use that one. It has a bend sequence here of 6 different bends. I'll say, okay. And now I want to see a simulation of what it's found. Hit play. You can do this for any 3D part, 2D part. You can even draw, you know, a 2D profile with your finger on the screen, and it'll show you images like this. So we're all done. All I got to do now, if I want to bend this, is go to Output, and then it'll make code for the Mitsubishi motors on this machine. All the back gauges of all our machines are Mitsubishi motors, and the motors on the RAM of these electric machines are all made by Lenz in Germany. But it'll make a code for all of them, and then when you start forming and pressing on the pedal, you're going to see this. And the operator, of course, can always, you know, examine this, a new part. He can look around and see what's going on. He can pan around. He can go to preset orthographic views on here and see stuff like this, or come back to where he was. Well, thank you for watching this short video. There's a lot more we can get into, but this is the essence of the DDM Electric Series press brakes. Again, I'm Casey. If you have any questions, go to www.dennerusa.com, and we'll have a whole bunch of more videos and information for you. Thank you.